Alright, this particular video again is going to cover a few things because, well, there's a few things I want to talk about. Most recently, well, as of the other day, went ahead and updated DragonOS Focal and DragonOS Pi 64. So both builds address some CVE things that were out there. Uh, there was quite a few updates to SDR++ and its server capabilities, a lot of updates to SigDigger, a lot of updates to Gqrx, and there's always a lot of updates to SDR Angel, and they all have some sort of server component to it, which I've talked about a little in the past. So I figured because there was so much, might as well just all talk about it at once here, or talk about it all at once. So we'll start out with SDR++ though. So SDR++, I have this is all running on DragonOS Focal, a laptop sitting here, pretty decent power behind the laptop. And also we have a Raspberry Pi, which is updated here with the latest kernel and a lot of software updates to it. So if you want to run a server and a client with SDR++, this is pretty much how you can do it. It doesn't have to be a Raspberry Pi. It can be whatever you want. But I have set up on here, this is pretty much brand new flashed Raspberry Pi 4 with, well, there's actually, since we're going to do a few radios, we'll check out SOAPy and see what we've got here. So we've got an RTL-SDR, Airspy HF plus the Discovery, HackRF 1, and a RTL-SDR. Shouldn't be too big of an issue running, well, I guess we'll find out, all four at once here. And they'll all be doing things slightly different. I'm thinking about this. We'll probably put the, I guess we'll do the Airspy on the, we'll do the, let's see. Yeah, we'll do the Airspy on the SDR++. So let's check this out. So SDR++ server, that'll start it up on any interface. So essentially 0.0.0.0. First time I'm starting it. So now the server is running and listening on the Raspberry Pi. I'm going to try my best to explain this the best as I can. In this particular case, my understanding, SDR++, the IQ data is going to be sent back to the client, and the digital signal processing, I guess you'd say, would be happening there. It's still pretty bandwidth efficient, and it's only going to get better. So we'll jump back over to the client side, and if we take a look at our options here, come down SDR++ server, change the IP address to the Raspberry Pi. We should be able to connect. At that point, you connect and you've got access to just as if you were local. So we know we've got an Airspy, we've got an Airspy HF, we've got, what else? We got HackRF, and we got an RTL-SDR. So we have access to all four radios here locally. We'll go with the Airspy, and I'm not going to spend too much on any one particular piece of software because there's a lot to go into. I'm just focusing on the server client setup, and maybe if I get time, go into more detail on each particular application, or check out some of my other videos where I talk about each individual application. So I'm going to turn the audio down here. At that point, we're connected to the server. Once we hit play, and we'll take this down to 2.5 because I'm going to try and run all four at once. So now we're connected, we're seeing we're streaming. We got audio. So we got audio, and we've got so we can check out compression, which is built in there now. So we take a look, and it really depends on what SDR, what frequency. I noticed with the Airspy HF earlier with compression on it, nearly cut this in half. So I guess it's just going to kind of depend. And I think it even says that on the SDR++ site, or somewhere I saw it, that that's going to fluctuate. Anyways, so we've got that connected, and I'm going to go ahead and I'll just leave that connected. Come back here. We'll jump back over. Let's see. And actually, I should have thought about this because it's going to take a while. We'll go ahead and we'll start up. I'm just going to start up the full SDR Angel GUI on the Raspberry Pi. The reason why it takes so long to start up, and you can address that and tweak it. The allocate FFTs there, it's building that wisdom file. For whatever reason, it takes forever on the Raspberry Pi or ARM or Arch64. It's talked about in the forums. You can kind of get around that by pre-generating that wisdom file and then pointing your configuration at that. I just didn't do that out of the box with the image because it, you may want to adjust it and set it up to your needs. So we'll come back to this. It's going to take a while to start. Let's take a look at what else do we got. We'll take a look at SigDigger and its server component piece, which is pretty unique, and it's different than the other solutions in that on the Raspberry Pi, the digital signal processing is going to be happening there, and very little information is being sent back. And when I say very little, it's a very little bandwidth usage is happening when I connect to it with the client. So the DSP is happening here, the audio and the spectrum updates, I hope I'm explaining that right, are sent back to the client. And to do that, let's see how we can do this here. The command line options of SigDigger. Here you can see I'm using this particular tool. Let's see if we can. We'll make a profile. Now it's probably going to come up and see some of the radios here. That's fine if we generate for all three. It's probably not seeing the Airspy because it's in use right now. So we've got profiles now that are generated. And so if we do, actually, you know what? We will, let's see, we'll take a look at those profiles so you'll understand where they're at. In your home folder and a hidden directory here, we've got suscan config sources. And once you get used to looking at these files, it'll be fairly easy to understand. I think I'm going to do the HackRF on this particular. I'm just looking at the bandwidth and sample rate. Looks like 1 meg. 3, 4, 5, 6. That's fine. I'll leave that like that, and we'll go with connecting to the HackRF here. So you could change those sample rates there. Some of these settings you need to set before you start the connection. Like maybe you want your center frequency on something other than 433. Maybe you want your bandwidth and sample rate a little higher than what is preset there. You can adjust those settings so when you connect, which I'll show you here in a second, that's where you'll be. That's where you'll be starting at. The other thing, you can make additional configuration options, and they'll start on different ports. So if we do dev serve if equals 0.0.0.0, those profiles that we created, and you can create numerous profiles, will be served up on different ports. So each one of those ports can be connected to and viewed via different SigDigger clients. So they're all accessible on different ports there. So we'll remember 28003 was for the HackRF. So we'll jump back over to the client side. We'll come over here to SigDigger. Another thing with SigDigger, we'll change real quick. We'll enable OpenGL, which this works both on my laptop and on my Pi4 that I've tested. We just got to close it real quick and open it after we make that change. Now the waterfall bottom area should be powered by OpenGL. We'll come here, change to remote. Again, we'll put the IP address of the Raspberry Pi, and we want to set, and we see SDR Angel literally just opened up on the Pi. We'll set 28003. So 28003 we'll leave anonymous. Hit OK. Hit connect, and we can see we've got our sample rate there, which was what was set, the 433. We've got access to our gain settings. Not 100% sure for the HackRF. For some reason or another, the DC remove spike is still there, so just factor that in when you're tuning your frequencies in. You might want to offset that a little bit. You can see we can adjust, change our gain. And I'm trying to think what is on. There's only a little, not a very good antenna on the HackRF. So we can do demodulators here as well. Okay. Some different unique features of SigDigger once we're looking at a particular frequency. Probably wouldn't really do it on FM here unless you're trying to look into the RDS. We can go down to inspection. If you want to capture that frequency for a little bit, you can, let me just blow it up. You can left click, hold. You'll see it starting to that time domain capture. You release. Now you can look at that particular frequency a little bit closer. A lot of options here that I probably wouldn't do the program justice trying to explain everything, but just understand that it is available. You've also got inspectors that you can open up. And I'm just going into this a little bit more because it's pretty unique to SigDigger. You've got capabilities where you can do subcarrier inspections, data forwarding. I've even, in some cases, forwarded over to GNU Radio. So anyways, we'll close that out. Minimize this back down. So we've got our SigDigger and our SDR++. Let's take a look at SDR Angel. Come over here. We'll minimize the two servers that are running. Careful not to close them. Now SDR Angel has a server portion as well, and I've talked about that in another separate video where I go pretty in detail on how to set up the API or the web portion to access the API, so you don't even have to have the GUI open, the graphical user interface here, to get this going. But for this video, or for the sake of getting this up pretty quick, I'll try and do it from memory here. In this case, we'll take a look. Matter of fact, I wanted to show this anyways. The Airspy HF actually has no problem in either the USB 3 port or the USB 2 port on the Pi. So I thought that was pretty interesting. Seems to be maybe an issue on DragonOS Focal, where the Airspy HF really works on every other application there, but for some reason the SDR Angel, you don't see anything. It's not actually opening up the receive portion, and I found a way around that, which was basically to set the USB ports on the laptop to USB 2, and that pretty much worked for me. But we'll take a look at running it here on the Raspberry Pi, and we can see right away of the spectrum there is being populated. And we can look at the different settings. You've got gain. You can pick between HF, VHF, sample rate. But what I want to take a look at is sending this over the network. So let's see. Let's take a look here. We'll do remote channel sync. Apply. Okay. This IP address, I am going to put the IP of the laptop in there. All right, so I'm going to put the IP of the laptop in there. I already checked it. We got 192.168.0.146, and we'll go with 9090 should be okay. We'll hit set, jump over to the laptop. On this end, we're going to do, let me blow it up big here. We'll go to input. We'll put remote input. And let's see, we want to put in 192.168.0.119 data. I think this should be 192.168.0.119. Let's see. I always forget how this works. Okay, so set, we got green, green, and that should be receiving from the other end. You'll notice this says R19. I've updated all the applications on this laptop testing. I just haven't reflashed from the fresh. Let me see here. Let's see, 192, 119. I'll get this mixed up. Let's see. Okay, so, all right, so the remote end is the 119, is the Pi. The data, I put the IP address of the laptop. The Pi is sending there to 146.90.90. For some reason, it always confuses me. So here's a workaround. If you have this kind of setup to get the HF, well, obviously you can do the what I mentioned about the USB 2.0, but here we're sending from the Pi, the Airspy HF, over the network. In this case, it's just a local area network here. It's wired. And we've got the HF coming in. We could do SSB demodulation here. Let's see. Let's see, I can kind of hear somebody talking right now. Volume, volume, volume. Let's see. I always get it mixed up. LSB. What frequency are you? So you need to change. I don't think there's any way. What am I on here? No, it says 9 kilohertz. I don't know. I'm not gonna change anything because there's audio right now. You can mess with it and go with your LSB, USB. I'm not going to talk super in depth on that. I just want to show again that this works. Matter of fact, I'm going to turn the volume down or blast it. So there you go. Let me mute this. Okay. All right. So at this point, we've got 3 radios up on the Pi, remotely streaming over the network. Let's see, let's get one last one here. So we'll minimize this, leave it running in the background. Let's see where we're at here. Okay, not too bad. Now let's go with a classic here, and we'll do RTL TCP. We'll do -A 0.0.0.0 is fine. This should pick up the RTL-SDR, and I didn't change any other settings. We'll come back over to the desktop, give Gqrx full screen here, device, RTL-SDR Spectrum server, change local host 192.168.0.119, leave the port default, input rate is fine, just take it down a little bit here, decimation, audio, bandwidth, that's fine, should be fine. Okay, I can see I'm connected to the server here, and there we go. So now we've got the RTL-SDR with the latest Gqrx. We've got gain settings here. And I got audio there. I'm looking the RTL-SDR. So we've got audio there. Now obviously this is probably a little taxing on the everything kind of streaming here at once. But at least it allows me to cover 4 different things in one video. So you can see there is no reason why you can't stream SDRs over the network. There is a lot of options. Each have unique things, and yeah, pretty easy to get set up, and can't really think what else to cover, but that's all in the latest DragonOS Focal and the latest DragonOS Pi 64. All right, there you go, and have a great weekend.